Hello everybody, thanks for tuning in again, doing another segment on synergetics and nuclear structure. Today I'm going to explain how synergetics links string theory to particle physics. I'm hoping that people in string theory are interested in this. I think they've been trying to do this for decades. In string theory there's something called the equality case. Within these Calabi-Yau manifolds, which they've discovered, they have found out that there's a particular ratio which holds true. That ratio is called the equality case. It says that 3 times the second Chern class is equal to the square of the first Chern class. These Chern classes are different aspects of the Calabi-Yau manifolds. And what's happening then is that now that we understand how we ratio the cube's volume in whole rational units compared to the tetrahedrons, we see its volume now ratioing in accord with each of its frequencies volumes ratios to the frequency to the second power times 2 volume in accord with string theory's equality case. X to the second power is equal to 3 times y. For instance, the cube's volume ratios its first frequency to its second frequency volume. The 1 frequency is placed into the formula. 1 to the second power is 1 times 2 is 2. That's how we're deriving this number here. The volumes then of the first frequency cube is 24. Volume of the second frequency is 192. 24 to the second power is equal to 3 times 192. The cube's volumes continue to ratio like this ad infinitum. The second frequency ratios to the 2 times 2 times 2. 8th frequency, 192 volume for the 2 frequency to the second power divided by 3 is equal to 12,288. The square of the first Chern class is equal to 3 times the second Chern class. 3 goes into the ratio. 3 to the second power is 9 times 2 is 18. So 3 frequency ratios to 18 frequency in accord with x squared equals 3y. 648 to the second power is equal to 3 times 139, 968. The 4th frequency, 4 to the second power is 16 times 2 is 32. Ratios to the 32 frequency. In accord with 1536 to the second power is equal to 3 times 786,432. Once again, these ratios continue ad infinitum. Now, I'll put these 3 formulas here so we could kind of identify them as basic mathematical structures within the nucleus of the atom and within nuclear buildup. 2t plus 1 is equal to the number of orbitals on the subshells about the nucleus of the atom upon which the electrons are revolving, rotating, etc. On that 0 s subshell, 0 times 2 plus 1 equals 1 orbital. 2 electrons on each orbital. Pauli exclusion principle once again, right? Only 2 electrons on each orbital, 1 with half up spin, 1 with half down spin. On the p subshell, 1 times 2 is 2 plus 1 is 3. You have 3 orbitals. 2 electrons on each orbital for 6 total electrons. Added to the previous 2 electrons equals a total of 8 electrons. The d subshell, 2 times 2 plus 1 equals 5 total orbitals. Times 2 electrons is equal to 10, plus 8 is equal to 18 total electrons. The f subshell, 3 times 2 is 6, plus 1 is equal to 7 orbitals. 7 times 2 electrons is equal to 14 electrons, plus 18 is a total of 32 electrons. Now, we'll notice that the 2, the 8, the 18, and the 32 are identical to the 2, the 8, the 18, and the 32 that are ratioing the cube's volumes to the equality case within string theory. We'll notice here that the tetrahedron's formula for the total number of closest packed unit radius spheres on that external layer, that formula is 2 times frequency to the second power plus 2. We'll notice then that in the first frequency we have 2 plus 2. The second frequency we have 2 plus 8. Third frequency, 3 times 2 is 9, times 2 is 18, plus 2. The fourth frequency we have 32 plus 2. In Synergetics, Buckminster Fuller teaches us that for the external layer of closest packed unit radius spheres, the 2 becomes very negligible and small in size compared to the rest of the accumulating numbers at high frequencies. And negligible by meaning 2 compared to the rest of those high numbers is not a lot of numbers. But what that 2 acts as is your axes of spin. So those are the 2 points for your axes of spin. Those 2 spheres represent that. Notice then how our symmetry of phasing and symmetry of development in nuclear structure shows a symmetrical aspect between the tetrahedrons formulas, 2, 8, 18, 32, the electrons available on the subshells, 2, 8, 18, 32, the ratio of the volume compared to the equality case in string theory, 2, 8, 18, 32. Now, I've been giving a lot of lectures and we could all start to say, oh, it's just a whole lot of coincidences, but sooner or later we need to start paying attention to these things. I want to, before I leave, just bring up one reminder that I had spoken of in one of the previous discussions, how 2t plus 1 is a symmetrical equation which exists and is used in order to calculate the total number of closest packed unit radius spheres in the cube's vertexes. Those are the only topological external and internal vertexes, or closest packed unit radius spheres. Interesting, the cube's vertexes are ratioing 2t plus 1. Its volume is ratioing as string theory's equality case, and the total number of electrons available on the available on the subshells and orbitals of the subshells of the electrons. Before we leave also, if you take T and you replace it by the vector equilibrium's third frequency volume, and you divide it by the cube's second frequency volume, 540 divided by 192, and every third frequency vector equilibrium ratios to every second cube's frequency volume in the same way, so that 2 times t plus 1 is equal to 6.625. It's 2.8125. Many different symmetrical aspects of phasing or developmental groupings of aspects of universal affairs regarding geometry and the nucleus of the atom, particularly Synergetics energetic vectorial geometry, is leading us to some very interesting clues. I'm going to leave you with this, you guys, and thank you very much until my next lecture.